Assalamu alaikum warahmatullahi wabarakatuh. Apologize, there will be no other students in class today. Um, since I had to go somewhere, so I will end this meeting abruptly. So I decided to not uh, not- so sorry. Uh, Hence there will be no other participants, but instead it will just be me trying my best to explain how to solve these questions, inshallah. Let's start. Question number one, recording, right? Yep. What is not a reasonable estimate of the physical property indicated? Okay. 2000 watt for the power dissipated by the heating element of an electric kettle. 400 meter cube. Whoa. 400 meter cube for the volume of water in a swimming pool? Nah, man, that's too much water for a swimming pool. 500,000 Newton second for the momentum of a lorry moving along a road. 600 Newton for the weight of a fully grown racehorse. 600 Newton means around 60 kg. Okay, this is even more weird. Even like no, normal persons weigh 60 kg and horses they weigh way more than 60 kg, man. So I think it's T. I think it's a very big swimming pool to have 400-meter cube of water. Wow, but it's T. Which quantity could have units of Newton meter per volts? Cha. Acceleration is meter second square, right? Charge is uh, ampere second. Current is ampere Newton meter per volt. And resistance is voltage per amp. Okay. So it couldn't be acceleration. Where will volt come from in acceleration? For charge, no, that charge is basically the current over time, right? And current is basically force into distance. Oh, wait. Force and distance is work done, right? Work done is force into distance, and that's Newton meter. And we know that P is equal to VI. So I is equal to P over V. Oh, okay. So P is Newton meter per time. I is equal to Newton meter voltage per time. And we know that I is equal to Q over T, right? So Q over T is equal to Newton meter per voltage T. T cancels out. So charge is basically the answer. So this was a fun question. An object is acted upon by two forces 10 Newton in the vertical direction and 6 Newton at 40 degrees to the vertical as shown. What is the resultant force acting on the object? Okay, so if we draw this 6 Newton force over here, then the resultant. In fact, let's do the Pythagoras, okay? So let's make the components of this force. This will be 6 sine 40, and this will be 6 cos 40. So the resultant will be 6 sine 40 whole square plus, okay, 10 minus 6 cos 40 whole square under root. Since we're taking vertical and the horizontal, 6 sine 40 square, 10 minus 6, 6.6 Newton. Yep, I think it's this steel. Yep, steel on the left. An analog ammeter with a range of 0 to 250 milliamps is connected into an electrical circuit. Diagram shows the ammeter's display. What is the reading on the ammeter? Okay, so its range is 250 milliamps, right? So, and we have a total of scale to 10. So let's divide 250 by 10. You get 25 milliamperes per. So this is 25, this becomes 50, 75, 100, 125, 150, 175, 200, 225, 250. And if 10 is 25, so 100 will be 2.5. So 75, 177.5, 180, 182.5. Wait, no. Oh, wait, no, it's not 100. Sorry. It's 50 actually, right? 5, 10, 15, 20, 25. Yeah, but it's 50. So it's 5. Right. Okay, so 180, 185, 190, 190 amperes. See? Yep, HT on the. I don't think this question will come because analog ammeters are out of date now on the. Students take readings of the volume of a liquid using three different pieces of measuring equipment X, Y, and Z. The true value of the volume of the liquid is V. The students' results are shown. How many pieces of equipment are precise and how many are accurate? Okay, so precise, this and precise. This is precise and this is also comparatively precise. Wait, it's not, this is precise. But this here, this seems sus, man. And for accuracy, uh, this seems accurate, and this also seems accurate. This is inaccurate. So I'm gonna go with, okay, so answer is D. If this seems precise, okay, this is also quite precise. Yep. This will touch boundary anyhow. Which graph shows the variation with time t of the velocity v of an object falling vertically downwards in a vacuum? Velocity, velocity. It's increasing, right? It's increasing like this. Yeah, velocity will increase like this since there will be constant acceleration to d. Yep, that's the answer, Alhamdulillah. A projectile is fired from point P with velocity v at an angle theta to the horizontal. It lands in point Q, while horizontal distance r from P. A resistance is negligible. Which equation for r is correct? Okay, so we know that um, S is equal to ut plus half at square. S is r, u is, we don't have t, right? That's a problem. Okay, I'm sorry. Okay, so we need to calculate the time first as well. So we know that to calculate time, uh, know that the horizontal vertical displacement is basically going to be zero, right? SV is equal to ut plus half at square. The vertical displacement is zero. The initial vertical velocity is v sine theta plus half a is minus g t square. So uh, minus g over 2 t square plus v sine theta is equal to v sine theta t 0. So t is either 0 or t is equal to v sine theta divided by 2 v sine theta divided by g. That's t. What you get? Since it's a minus, it minus cancels out 2 multiplied. Okay, so we got t. Now just put in the s horizontal. So horizontal velocity is v cos theta, and t is 2v sine theta with g plus half. The horizontal acceleration is 0. The only force acting is gravity, and there is no force in the horizontal direction, so the horizontal acceleration will be 0. T square, it doesn't matter, it will cancel out anyway. So we get 2v sine theta, 2v square sine theta cos theta over g. Is it P? Yeah, this is what it is. On the run. A book of weight W is at rest on a table. A student attempts to state Newton's third law of motion by saying that action equals reaction. If the weight of the book is the action force, what's the reaction force? So it's talking about the weight, right? The weight is the force on the book due to the earth. So the reaction force will be the force on the earth due to the book. I think it's going to be C. Yep. 4 balls are dropped at the same time from the top of a very tall tower. There is no wind blowing. Which ball hits the ground first? Okay, so it has more mass and has more weight. If P mg, the one which has more mass will have more weight. So C and D won't be, since they have a bigger diameter and so bigger surface area, so they have more air resistance. So this is the highest weight, and it'll have the highest acceleration in V. Yep. If you don't understand a question, if you're seeing my uploaded video, and just ask in the comment section, okay, and hopefully I'll answer soon, inshallah. A nitrogen molecule P traveling at speed of 320 meters per second in a vacuum collides with a stationary nitrogen molecule Q. After the collision, P travels at a velocity of 180 meters per second at an angle of 55 degrees to its original path. Q travels in direction at an angle of 34 degrees in its initial path P. Assume that there are no external forces acting on the molecules. What is the magnitude V of the velocity of Q? What is the magnitude V of the velocity of Q after the collision? Okay. So we know that the hold on. For this we need to know nitrogen molecule. I think we need to know the weight. So okay, so the mass of, let's say the mass of nitrogen molecule is m, and its mass is also m. This is also m. This is also m, since they are same molecules, right? So the vertical momentum is zero, right? So we know that the 180 m sine 55 will be equal to Vm sine 34, since they'll cancel out each other, since the initial vertical momentum was zero. So the final vertical momentum should also be zero. So if we subtract this from this, we should get zero. So we get is m cancels out, 180 sine 55 over 30 sine 34. 180 sine 55. We have 260 meters per second. A charged particle is placed in a uniform field. Okay, electric field is not in our syllabus anymore. A disk of radius r is acted upon by two opposite forces, each of magnitude f. The forces form a couple as shown. What is the torque of this couple? It's basically f into 2r, 2fr. Yep. It's basically force into the perpendicular distance of the forces. Uniform square sine of weight 40 Newton is suspended vertically from a stoppage by a horizontal range as shown. Okay. So this is the side view. The hinge is not frictionless when the sine is displaced from the vertical by an external force. Then it does not return to the vertical position. The maximum torque exerted by the hinge on the sine is 6 Newton meter. The sine is displaced by 90 degrees so that it is horizontal and then gradually released. At which angle of the vertical does the sine hang after the release? Okay, so this question, I think I'm gonna come back to it since I'm uh lacking a bit time. So just gonna skip it for now since I really can't understand the diagram. So just don't want to waste time on it. So even in the exam paper, if you like, if there's a question like this which takes a bit time for you to figure it out, just skip it and then come back to it later. It'll save you much time, inshallah. Each foot of an elephant has a circular cross-section with circumference of 1.4 meter. The elephant has a mass of 5,400 kg. The elephant is silenced with all four feet on the ground, and the pressure under each foot is the same. What is the approximate pressure that okay. So we know that pressure is equal to force over area, right? So we first need to find the cross-sectional area. So circumference is 1.4, so we know that 2 pi r is 1.4. So r is basically 1.4 over 2 pi. So the cross-section area will be 1.42 pi square 2 pi. Which is around 49 over 100 pi. So this is the cross-section area of 1 foot. So the cross-section area of 4 feet will be into 4, 49 over 25 pi. And this is the area. So, so the force will be 400 into 9.81, which is the weight. You have 49 over 25 pi. This will be the pressure on all the 4 feet. 400 into 9.81. So the whole total pressure is 85 K. So the pressure one, yep, 85 K pressure. The stone is falling vertically through the air at constant terminal velocity. I'll again come at this question again, since there's one thing that is still not clear to me, but I'll come back to it again, inshallah. The stone is falling vertically through the air at constant terminal velocity. Which energy change is occurring? Okay, so gravitational potential energy to kinetic energy of the stone. Wait, no. It says constant terminal velocity. That constant velocity, the kinetic energy is the same, right? So it will be gravitational energy, the thermal energy. Yep. An object of weight 12 Newton rests on a platform on top of a container with two pistons, as shown. The container contains a fixed mass of gas, and the pistons are free to move. The plunger is slowly pushed 4 centimeters to the right. As a result, the object slowly moves upward a distance of 0.5 centimeter. How much work is done on the object? So for it to move 4 centimeter, 0.5 centimeter upwards, and it has a weight of 12 Newton. So the work done is 12 into 0.5 into 10 negative 2 centimeter. Zero point zero 0.06 joules. The constant force F acting on a car of mass m moves the car up a slope to distance s at constant velocity. The angle of the slope to the horizontal is alpha. Acceleration of free fall is c. What is the ratio gravitational potential energy gained by the car work done by force F? So we know that the so GP is basically mgh, right? So we need to know mgh over work done by force, which is Fs. So H, we need to find H, right? So H, know that sine alpha is equal to H over S. So is equal to S sine alpha. So mg S sine alpha over Fs. SS cancels out. So mg sine alpha over Vt. Yeah. What is the definition of power? Power is the product of force and velocity. No. Wait, what? It is force or velocity. Sorry. What? P is equal to Fp. Okay, so it's not a definition. Power is the rate at which work done. It's a derivation, not definition. No, no. A steel bar of circular cross section is under tension T. As shown, the diameter of the wide portion is double the diameter of the narrow portion. What is the value of stress in the wide portion? Stress is force over cross sectional area, right? So it's if the diameter of this is D, let's say this is D2, and we know that D2 is equal to 2D1. So A1 is basically D over 2 whole square pi, right? Or you can say D square pi over 4. So A2 is 2D over 2 whole square pi. You cancel out, you get T square pi. So basically, we're getting F over D square pi over 4 divided by F over D square pi. Wait, no. That's in the white portion is F D square. F cancels out. D square pi into 4 over D square pi. Did D? Wait, hold up. 1 over D square pi divided by 1 over D square pi over 4. So we get 1 over D square pi into D square pi over 4. Yeah, 0.25 square. Two guitar strings are attached by tensile forces. String X is stretched by tensile force F that causes an extension X. String Y is stretched by tensile force 2F that causes an extension 2X. String obeys Hooke's law. What is this? Almost the same question, man, Smala. The strain is extension over original length. Okay, it's talking about strain energy or elastic tension energy. So elastic tension energy is basically half Fe, right? So strain energy of X is basically equal to Fx over 2, and strain energy of Y is 2F2x over 2Fx. So strain energy in X over strain energy in Y, get Fx over 2 divided by 2Fx. So we get this goes over here. 6. Number 4? Yeah, 1 over 4. Two lasers emit light in a vacuum. One laser emits red light, the other emits green light. Which property of the light from the two lasers must be different? Their frequency will be different. Since their wavelength will be different and speed is constant. Two particles in the progressive wave are a distance of 10 centimeters apart. The two graphs show the variation with time t of the displacement t of the two particles. What could be represented by the two graphs? They're at a they're distance 10 centimeter apart, right? So that means that if they're 10 centimeter apart, so that means this is 5 centimeter, and this is also 5 centimeter. Particles in a longitudinal wave with a compression and nearest is rarefaction separated by 10 centimeter. I think this is correct. Yeah. Since this is like you can take this as a rarefaction, take this as a compression. Like in sound particles, it's something like this, right? So this is the compression and this is the rarefaction. So let's say this is the positive amplitude, this is the negative amplitude. So from here to here, i.e. this distance is 10 centimeter. The sound wave is detected by a microphone that is connected to a CRO. So CRO is a waveform. Time base is set to 20 meters per second, 20 millisecond, microsecond. What's the frequency of the sound wave? So frequency is 1 over time period, right? So time period of one wave is okay. So the time period of 1.5 wave is if 1.5 waves take how many? 1, 2, 3, 4, 5. 5 into 20 meters millisecond microsecond. So one take 5 into 20 over 1.5 microsecond, and then you divide by that 5 into 20. So one takes 1 over 15,000 seconds. So 1 over 15,000 is 15,000 hertz. Yep. It's a person stands at the side of a straight railway track. A train moves towards the person and emits sound from its whistle. The person hears a sound of frequency 1690 hertz as the train approaches him. Okay. Person then hears the sound of frequency 1500 hertz as the train moves away from him. Speed of sound in air is 340 meters per second. What is the speed of the train? So we know that the FO is basically frequency of the source, the speed of sound over speed of sound to plus minus speed of the source. So we basically have two variables, right? We need to find V. So for when it's coming, when it's approaching him, it will be minus, right? So Fs, V is 340, 340 minus V. So we get 574,600 minus 1690 V equal to 340 F. Or you can say that F is equal to F source 340. Now for the second equation, when it's moving away, we have frequency 1500, Fs V 340 over 340 plus V. So we get 1500 V plus 510,000 is equal to 340 Fs. Now we just substitute the force, the frequency of the source. So we get 1500 V plus 500,000, 340, 574,600 minus 1690 V over 340. 340, 340 cancels out. So we get 1500 V plus 6090 V equal to 74574,600 minus 51,000,000. So V we get is 64,600 divided by 3190. 20 meters per second. Yep. Which list shows EM waves in order of decreasing frequency? Yeah, रेडियो वेव्स तो सबसे ज्यादा फ्रीक्वेंसी होती है ना. सॉरी, सबसे कम फ्रीक्वेंसी होती है, जबकि वेवलेंथ सबसे बड़ी होती है. इनकी सबसे ज्यादा फ्रीक्वेंसी गामा रेज ये है. सिंस अल्ट्रा वायलेट की इंफ्रारेड से ज्यादा फ्रीक्वेंसी होती है. आपकी विजिबल लाइट है ये. आप आई थिंक आई जस्ट शेयर दीज नोट्स व्हेन आई upload the video. See, ultraviolet has, okay, frequency. You can see um gamma rays is frequency 20, about 24, while radio waves have only 1,000 frequency maximum minimum hertz. Pipe of length L is open at one end, closed at the other end. Loudspeaker is at the open end and emits a sound wave into the pipe. When a stationary wave is formed, there is an antinode At the open end of the pipe? Okay, so this is the speaker. Okay, so here's an antinode. Which wavelength of sound could be used to produce a stationary wave? No, there will be a node over here. So this can be a stationary wave. This is the first, right? So we have one node and one antinode. So this is L over 4. Sorry, this is this whole is one wavelength, right? So we just forming this part, so we need 4 L. Uh, so if we check this, there is two nodes. Because this is this impossible. This can be. We have two nodes. So now L, this is 3 over 4 pi, right? 3 over 4 lambda is L. So the wavelength will be 4 L over 3. Yep. Which diagram best shows how water waves diffract when they pass through a gap in a barrier? Yeah, well, they don't diffract like this. This also seems a bit sus since the gap is very small. I think C seems the most correct to me. But no, it's B. Yeah, okay. The wavelength is changing over here, right? That's why. Since see this wavelength over here, then it's different. Sorry. In a two-source interference experiment, light of a single frequency is incident on a double split. Light waves emerging from the slits are coherent. What is meant by coherent constant interference? Parallel beam of light consists of light of wavelength 4 nanometer, light of wavelength 3 nanometer, light the normal diffraction rating. Diffraction maxima for the two wavelengths overlap only at an angle of 31 degree from the direction of the incident light. What could be the line spacing of the diffraction rate? Okay, remember? So we have the angle. We know that the E sine theta is equal to m lambda, right? So um so we have this is common, right? That Wait, I think I'll also like come back to this question again, inshallah. Positively charged part of electric field known as syllabus. Diagram shows two parallel metal plates being separated by distance of 5 millimeter. There is a potential difference of 700 volt between the plates. Electric field again, not known as syllabus. Wedge-shaped metal conductor of length L, varying width and uniform thickness, is connected to a cell. Which best shows out the average drift velocity of the electron. So we know that the as you name right. So drift velocity is proportional to. Now we need to know. Okay, so the charge density will be constant, elementary charge velocity will be constant, and the current velocity will be constant since it has a fixed resistance, right? So V is directly proportional to 1 over and directly proportional to the cross-sectional area. So as you can see, since it has the same width, thickness, and its width is increasing, that means that the uh, cross-sectional area is also increasing, and its uniform thickness. So it's basically its its length, its width is increasing. So we know that the velocity will decrease. So B and T can't be the options. Now we need to figure out whether it's A or it's C. Can L, V can never be zero, even if it reaches L. If velocity will never be zero, then it has to move with current. So I think it's going to be A. Okay. Power output of an electrical supply is 2.5, 2.4 kilowatt at a potential difference of 240 volts. Two wires between the supply and kettle each have resistance of 0.5 ohms. What is the power supply to the kettle and what is the PDA across the kettle? Okay, so we know that these will dissipate power since they have resistance. So the power they will dissipate will be, so one wire will dissipate 240 square over 0.5. Hmm. Okay, let's calculate the current. We know that P is equal to PI, right? I is basically equal to 2400 to 40. The current is 10. So the power they dissipate is in fact 50. Yeah, is equal to I square R. So this dissipates 50 watt, this dissipates 50 watt. Okay, so power dissipation we use basically I square R, I remembered. So they both dissipate a 100 watt total. The power supply to kettle will be 2.3 kilowatt. And PD, the voltage they'll use is zero point 0.5 into current is 5. So this get 5 volts, this get 5 volts. So I think it's going to be a, yep, it's a on the graph shows the, okay, so this is the last question. The graph shows the variation. I'll continue the rest later on, inshallah. The graph shows the variation with potential difference P of the current ion components X, Y, and Z, which locally identifies the component. Okay, so let's first find the filament lamp. We know the filament lamp will be this. Since as the current increases, the resistance increases, so voltage increases. So filament lamp is Z. So is it P? No, it can't be that easy, man. So P. Just need to find filament lamp. Okay. Inshallah, I'll finish the whole paper. Then I'll upload the recording soon, inshallah. Assalamu alaikum. Now, okay, let's continue where we left off. A wire of resistance 9.55 ohm has a diameter of 0.28 millimeter. Resistivity, what is the length of the wire? So we know that the resistivity is rho L over A into pi L. The length, the resistance is 9.55 ohm into cross-sectional area, there's the diameter, divided by 2 to get the radius, whole square pi r square, divided by resistivity, 4.9 into 10 power negative 7. And we should get the length to be, sorry, I'm using my phone as calculator, so it's a bit slow to process. Pi. Getting 1.2. That's the correct answer. Cell of constant EMF but with internal resistance is connected to a fixed resistor R using a potentiometer. A voltmeter measures the PD between terminals of the cell. Which statement explains the change in the reading of the voltmeter as contact Z is moved towards index with the potentiometer? So, okay. So as you move the potentiometer from X to this endpoint, this resistance will increase, right? Since it's a fixed resistor R, right? No, yep, X. It's saying what? Okay, so this the current is going from here. Okay, same thing. So if you're moving towards end X, its resistance is increasing. So if its resistance is increasing, that means that the total, wait, we'll be considering this part. Yeah, sorry. We'll be considering this part, okay? So its resistance is decreasing. So if its resistance is decreasing and since it's parallel with X, that means that its total resistance will decrease. That means the current increases. Current to the cell increases. And that means that voltage also increases. Wait, what? Current is decreasing. Sorry, it's just my mind is just not working right now. I don't know why. Let's just come back to this again. Cell of EMF E and negligible internal resistance is connected to a circuit. Circuit has currents I1, I2, and I3, and PD is V1, V2, V3. Which equation represents the statement of Kirchhoff's first law? W is equal to R to the side. Current entering a point is equal to current sum of currents leaving the point. Two resistors are connected in series with 6-volt power supply. What is the resistance of the variable resistor R to give potential difference of 1 volt across the volt? Okay, so we know that 12K, let's say 12,000 or 12,000 plus R into 6 is equal to 1. The ratio method, so we get 12,000 plus R is equal to 72,000. So R is 60K. Nucleus of magnesium decays in nucleus X by emitting a positron. Decay is represented by the equation shown. Beta plus 1. What are the values of P and Q? Okay. Basically, what has happened is that in positron, when beta positive is released, a proton is converted into a neutron plus positron. So this will remain the same. P is 23, while Q will be 11. Since 11 plus 1 will be 12. In electron decay, beta negative, a neutron inside a nucleus changes to a proton. Which statement describes the quark composition of the nucleus during the decay? Okay, so a neutron has an up and two down. A proton has two up and one down. So basically, an down is changing to an up. The number of up quarks is the same. No, the number of down quarks is the same. No, the number of down quarks decreases by one. Okay, so now let's go back to the questions which we skipped previously. Program. Yep, okay. So basically, in this question, it's like it's an hanging board sign, or the old towns you will see it frequently. Um, so what has happened is the hinge sign is displaced vertically on external force. Okay, so they've given us the maximum torque by the hinge, that is due to friction. And the sign is displaced by 90 degrees, so it's brought here, and then it is gradually released. At which angle does the vertical sign hang after release? So it will not come to the vertical position in return since there is friction. So let's say the sign it hangs over here. Okay. So and its weight is 40 Newton acts over here, right? So it has at distance of 0.4 meter from the hinge. That means that if its weight is acting over here, that means this distance is 0.4 meter. And we know that the anti-clockwise moment, since we're supposing that it's coming down in a clockwise direction, is 6. So what we need is to find this angle, right? Theta. Okay. So we know that for the momentum of torque moment, need the perpendicular distance from the pivot. So we can say that sine theta is equal, let's call this t over 0.4. So d is equal to 0.4 sine theta. And w is 40. So wd is 6. is anti-clockwise moment is equal to clockwise moment, right? So 6 is equal to W, which is 40, to 0.4 sine theta. Theta from here, you get 22 degrees. And there was another question, I remember. Yeah, this one. Yeah. Okay, so in this question, we know that uh, T sine theta will be same, right? T sine theta can't be, like, since D is a single value and theta is 31. So that means that, and if the lambdas are different, that means that for is equal to n lambda, if this is constant, and then that means if lambda of both are different, that means that the n will also be the maximum order. The order of the maxima will also be different for them to be constant d sine theta. That means that n1 lambda 1 is equal to n2 lambda 2. So let's do n40. Take 1 as the smaller wavelength and n2 as 630. Okay, so now the easiest way to find n1 and n2 will be through mental math. You can see if we do by trial and error. We multiply 630 by 2. If we multiply 420 by 3, we get 1260, right? So this becomes 1260. This becomes 1260. See, like if you multiply 2 into 6 and 1200, this is 1200, and then it's 4 into 3, 1200, and then you get the same value. So we basically took the LCM of both these two values. Now we know that N1 and N2. So now we can easily find D. So D is, let's take N1, which is 3 into 420, 10 power negative 9 over sine theta, sine 31. 2.4 micrometer. Yeah, we'll also do this. This was wrong because drift velocity cannot be zero. Okay. So let's come back to question which we again skipped. Okay, this one. Assalamu alaikum. Okay, so basically, um, so the potentiometer. Okay, first there's internal resistance. I forgot there was internal resistance. There's internal resistance here. So when there's internal resistance, we know that the EMF is equal to the terminal potential difference plus the internal resistance. So the potential difference, terminal potential difference, uh, is equal to EMF minus the IR. Okay, internal resistance. Okay. So now check the potentiometer. Let's say it's at point X. Okay, it's moving. It's moving towards the end of X. Let's say it's at the end of X. At the end X. So this point, when the current it flows through this resistor Z. Sorry, let's say this resistor fixed as a resistance of R. Let's suppose. So at this point, when it's at this point, the current has two options. It can either go through this path where there is resistance R, or it can go through this wire where there is an infinitely small resistance, let's say 0.00001 resistance. So of course current will take this path. That means that resistance, the total resistance of the circuit will be R. This is R, right? Okay. Now let's say the NG, the contact Z is at this point. So now what it forms, it basically forms a parallel circuit, right? With two resistors R. So resistor at end X, its resistance is R. And let's say this is NY. And at NY, since it's parallel with the same resistance on both the wires, so it will be R over 2. So you can see the pattern. When it's at Y, it's at R over 2, and when it's at X, it's R. So that means that the resistance is increasing. So if the resistance is increasing, the current will decrease. And if the current decreases, so that means the internal resistance decreases. That means the terminal potential difference increases since EMF is constant. Hence, the voltmeter reading will increase because the current through the cell decreases.